This is Yidong Huang, Shuai Yao, Rongbing Zhou. We are presenting VR panorama image-based structural damage, localization, and quantification. Rapid damage assessment and structural health monitoring are very important in structural engineering, but this is a repetitive and labor-intensive process. Moreover, it can be expensive, as we need to send one or more actual person with equipment to somewhere else, and it might be dangerous, as engineers need to work right after disasters on the shabby houses. Therefore, we want to automate this process with machine learning. We also want to realize the whole thing in VR because a single image does not provide cues about localization, sizes, density, perspectives, which are very important in the context of structural engineering.
In order to recognize and localize damages in image, we train two state-of-the-art models, modified from RCN and Faster RCN. Faster RCN trained the region proposal network to output the bounding boxes of damages. To further improve the accuracy of localization and segmentation, we trained Mask RCN, which used fully convolutional network to output binary masks of localized objects. Region of interest align is applied in Mask RCN to adjust misalignment of region of interest to achieve more precise results.
We labeled 2,000 training images for Faster RCN using label image and 200 images for Mask RCN using label me. It is worth noticing that Faster RCN needs only 4 corner or coordinates for each object, but Mask RCN requires a whole mask layer for each object.
We got quite good results for both spalling and cracks on Faster RCN, which predicts accurate bounding box with high confidence. However, we did not succeed in achieving satisfactory results on Mask RCN. We can see from the resulting images that our model is definitely learning something, yet it either lacks in detection or in applying masks. This happens maybe because Mask RCN requires a large amount of training data, as learning from mask layers rather than coordinates can be hard, or because classes we choose are hard to learning. For example, cracks can take so many forms, color, shapes, and they're not real objects that pop up. They are instead some pattern or texture. After the successful detection and the localization of structural damages on Faster RCN, we also test our model on panorama images. However, due to a lack of VR structural damage images, we synthesize VR test data to see if Faster RCN works on panorama images. From the two images on the left, we found that Faster RCN worked pretty well on large spalling, which can be detected and localized with high precision. However, it turns out that Faster RCN tends to make spalling and cracks, especially when they are mixed with other objects in the background. In this project, we proposed a new way to detect and localize structural damages and achieve good results using Faster RCN. Our preliminary results on VR images are also accurate for large spalling and cracks. For future work, we hope to collect real VR images in order to improve the precision with higher confidence.